Hey everyone, Meteorologist Tucker Antico here, and instead of an update on your weather, I actually wanted to give you a crash course, or a bit of a refresher, on fronts and pressure systems. Now I think this is important because I show these all the time on weather maps, and it's good to know that everybody can follow along. But I also think it's just good to understand some more of the science in the world around you, and I think you can really learn something from this. So let's get started. We're going to begin with low pressure systems. And the one thing I want to point out first of all is that we have colder air to the north and warmer air to the south. Now this is just because we live in the northern hemisphere where it's typically going to get colder the further north you go and warmer the further south you go. Now the thing that's probably going to stand out the most to you here is the counterclockwise flow of air around this low pressure system. This is important because if you've ever stepped outside before we talk about a big storm front coming, it's oftentimes warmer than the day before. And that's because that counterclockwise flow of air pulls the warmer air which sits to the south into more northern regions. And this is sometimes denoted by a warm front. So that's why it may warm up before these systems approach us. On the backside, we see quite the opposite. We have that counterclockwise flow still, but it pulls colder air out of the north into more southern regions. And this can sometimes happen very quickly after a big storm system passes by. And this is denoted by a cold front. So that's what happens with low pressure systems, and high pressure is similar, but it's the opposite. And we typically don't have fronts associated with high pressure, but what happens when high pressure approaches us, usually from the west, is we get colder because we have that colder flow of air out of the north being pulled by a clockwise flow of air. And it's the same thing on the backside of high pressure. That clockwise flow of air brings warmer air out of the south and into more northern regions once that high pressure makes its way to the east of us, once it passes by. Now the other thing you may hear is low pressure is typically associated with bad weather, rainy, snowy, or stormy, while high pressure is associated with good weather, typically sunny. Now here's why that happens. In addition to air flowing around a low pressure system counterclockwise, something else occurs, and that's called convergence. And that's basically this flow of air being wrapped into the middle of a low pressure system. Now this can help bunch up moisture around the low pressure system, but the other thing it does, and more importantly, is it forces that air to rise, because as that air gets pushed into one spot, it only has one place to go, and that's up. That's the only place with free space. And when that air rises, it takes that moisture with it, and the moisture rises and cools and condenses. It gets smaller, it gets tighter, and that forms clouds. And once you have enough moisture, you form precipitation, which can form in the form of rain or snow. And that's typically why we get clouds and oftentimes precipitation with low pressure systems, the weather we don't typically like to see. Now again, high pressure is quite the opposite. We have that clockwise flow of air still, but we also have divergence. And that's that air moving away from the center of the high pressure system. And this brings nice weather because, first of all, it makes it tougher for that moisture to group up. But the other thing it does is, well, the air diverges in the first place because it's sinking. And as that air sinks, it makes it tough for any moisture to rise up with the air and form clouds. So we generally have drier conditions, and that creates sunnier skies, the weather that we like to see. And that's why we enjoy high pressure when it's overhead. Now, I hope you learned something from this, and again, I think it's always just good to understand our physical world, especially in meteorology, better. So again, next time you see me putting out weather maps, maybe you'll have a better understanding of the science and physics that goes along. And if this is new for you, I hope I taught you something new.